Yes friends, as in my previous lectures I had worked with you Carl Pearson's coefficient of correlation using direct method as well as shortcut method. Let's do some practical examples as well. For example, I'm putting you one example, just write down. It's a given, that is summation xy equals to 200. Just write down xy equals to 200. Summation x square is 6 to 5, whereas summation y the square is 100. We have to find the coefficient of correlation, that is r. So we shall apply the formula r equals to summation xy oblique summation x square and its whole under root summation y the square and its under root, and then it will be, let's put the values in it, that is summation xy equals to 200 oblique summation x square is 6 to 5 and its whole under root, summation y square is 100 and its whole under root. So it will be, let's do it with a calculator as well. 6 to 5 and its under root is 25. It's a 200 oblique 25 multiplied by 100 and its under root is 10. So it will be 200 oblique 250. Let's divide this, 200 divided by 250, and this will be 0.8. So this is a 0.8, that is high degree of positive correlation. So it's very simple formula, just write down. And sometimes the values are given and we have to solve the question, then we can use the formula of this as well, that is r equals to summation xy oblique summation x the square and its under root summation y the square and its whole under root. So next one, in the same lecture we shall also find some practical examples of probable error and standard error. Let's take the same question again, and we can also take n or the number of observations. Just assume it as we can assume it as 10. Let's take the 10 as number of observations. So now we have summation xy equals to 200, summation x square equals to 6 to 5, summation y the square equals to 100, and the number of observations n equals to 10. So for standard error it will be 1 minus r the square oblique n and its under root, 1 minus r the square oblique n and its under root. Let's do it, 1 minus, as we had got 0.8 as r, so it will be 0.8 and its whole square oblique n or the number of observations as we assume as 10 equals to 10. So here 10 and its under root. Let's solve this. 1 minus 0.64 0.64 oblique, the under root of 10 is 10. The under root of 10 is 3.162. 3.162 equals to 0.36 oblique 3.162. We got the value 0.36 oblique 3.162. Let's solve this with the help of a calculator. It will be 0.36 divided by 3.162, and it will be 0.11. 0.113 is standard error. So just write down the formula of standard error. It will be 1 minus r square oblique n and its whole under root. We can also find probable error by this as well. So we are going with the probable error. Let's do it. Probable error equals to 0.6745 multiplied by 1 minus r square oblique n and its under root. We can also quote probable error equals to 0.6745 multiplied by standard error, as standard error's formula can also has also applied in the same manner. So let's do it. 0.6745 into standard error equals to 0.6745 multiplied by 0.113, and it will be 6.6745 multiplied by 0.113, and it will be 0.076. So it will be answer. We can also do